Today we are going to learn about mastering Pandas Pivot Table filters, where you'll gain the skills to effectively use filters in Pandas Pivot Tables to extract specific insights from large datasets.
Welcome to our session on mastering Pandas Pivot Table filters. Filtering is an essential aspect of data analysis, allowing us to isolate and focus on the most relevant data points from large datasets. Pivot tables are powerful tools in data manipulation, offering dynamic data summarization capabilities. In this video, we'll explore how to apply various filters using Pandas, a popular library in Python for data manipulation and analysis. By the end of this video, you'll be equipped with the skills to apply advanced filtering techniques, enabling you to tailor your data presentations effectively. Let's dive in.
In this segment, we'll focus on applying basic filters using Pandas. Filtering in Pandas is straightforward yet powerful, allowing us to work with conditions to isolate data. Let's start with a simple example. Suppose you have a dataset of sales transactions, and you want to filter out transactions that exceed a certain amount. You can achieve this using Pandas by applying conditions directly to your data frame. For instance, you can use the following syntax: filtered_data equals df sales, greater than 500, where df is your data frame. This command will return a new data frame containing only the rows where the sales amount exceeds 500. Such basic filtering is fundamental in data analysis, helping you focus on the data that matters most. We'll also demonstrate practical examples to solidify your understanding.
Once you're comfortable with basic filters, the next step is to use multiple conditions for data extraction. In real-world scenarios, you'll often need to combine conditions to extract data that meets complex criteria. Pandas makes this easy by allowing you to use logical operators such as and, or vertical bar. For example, if you want to filter transactions that are both above 500 in sales and occurred in a specific region, you can write filtered_data equals df sales, greater than 500, and df region equals east. This command uses the and operator to ensure both conditions are met. Similarly, you can use the or operator to extract data meeting at least one of several conditions. By the end of this block, you'll be adept at combining conditions to suit your data extraction needs, enhancing your data analysis capabilities. Lambda functions are anonymous functions in Python that can take any number of arguments but have only one expression. They offer a compact way to write functions for custom filtering logic. In Pandas, Lambda functions can be particularly useful for applying custom filters that aren't directly supported by standard operators. For instance, if you want to filter data based on a nonlinear condition, such as extracting rows where the sales are greater than the average sales of the dataset, you can define this logic in a Lambda function. Here's an example: df sales. Apply lambda x greater than df sales. Mean. This command filters rows where sales exceed the average sales value. The ability to incorporate complex and specific criteria into your filters using Lambda functions is a powerful skill, enabling you to tailor your data analysis to meet precise requirements.
Dynamic filtering takes your data analysis to the next level by allowing the integration of user inputs into your filtering process. This approach is particularly useful when creating interactive data analysis applications where users need to specify their filtering criteria. In Python, you can use the input function to capture user input and adapt your filters accordingly. For example, you may prompt users to enter a sales threshold, and then use that threshold in your filter. Threshold equals in input enter sales threshold, filtered_data equals df sales, greater than threshold. This enables users to explore datasets based on their specific interests, fostering a more interactive and engaging analysis experience. By the end of this section, you'll understand how to implement dynamic filtering, adding versatility and user engagement to your data analysis projects.
Missing values are a common challenge in data analysis, particularly when filtering datasets. They can skew results and lead to inaccurate insights if not handled properly. Pandas offers robust methods for dealing with missing data, ensuring your analyses remain valid. The dropna function allows you to remove rows or columns containing nan values, while fillna enables you to fill missing values with a specified value or method, such as the mean of the column. For example, you can apply df.dropna subset equals sales to remove rows where the sales data is missing before applying your filters. Alternatively, df sales. Fillna df sales. Mean, in place equals true, fills missing sales values with the column's mean, maintaining data consistency. Understanding how to handle missing values is crucial for maintaining data integrity and ensuring your filtering results are both accurate and reliable. Filtering large datasets can be computationally intensive, potentially slowing down your analysis process. Therefore, it's important to consider performance optimization techniques when working with extensive data. Pandas provides several strategies to enhance performance, such as using query for efficient filtering, leveraging vectorized operations instead of loops, and ensuring your data frame is appropriately indexed. For instance, df.query sales greater than 500 can be faster than directly applying conditions, particularly on large datasets. Additionally, consider using data types that minimize memory usage, such as float32 instead of float64 where precision allows. By implementing these performance considerations, you can ensure your filtering processes remain efficient and scalable, even as the size of your datasets grows. To truly grasp the power of effective filtering, it's insightful to explore real-world examples where these techniques have been applied successfully. In the retail industry, for instance, filtering can be used to analyze customer purchasing behavior, identifying trends and preferences that inform marketing strategies. Financial analysts use filtering to isolate market movements and predict stock performance based on historical data. Healthcare professionals might filter patient records to study the efficacy of treatments across different demographics. Each of these scenarios demonstrates how targeted filtering can lead to actionable insights and drive decision-making processes. By examining these examples, you'll not only see the practical applications of the techniques we've discussed, but also appreciate the transformative impact effective filtering can have across various sectors. As we conclude, let's recap the key techniques we've covered in mastering Pandas pivot table filters. From applying basic and complex conditions to leveraging Lambda functions for custom filters and integrating dynamic user inputs, you've learned how to extract precise data insights effectively. We've also addressed handling missing values, optimizing performance for large datasets, and explored real-world applications. With these skills, you're well equipped to enhance your data analysis capabilities. I encourage you to continue practicing these techniques, exploring new datasets, and applying your newfound knowledge to real-world scenarios. Thank you for joining this session on mastering Pandas pivot table filters.